Okay, so let's get into some examples then involving antiderivatives. So the directions here ask us to find all functions g such that for number 1, g prime of x is equal to 5x to the 1/4 power minus 7x to the 3/4 power. Okay, so the first thing we have to do if we want to find the antiderivative of this function, and I know I'm finding the antiderivative because we are given g prime and asked to find the function g. But the first thing I have to do is I have to look at g prime and determine if I can take the antiderivative of g prime the way that it's written right now. Or do I have to do some algebraic manipulation to my function in order to put it into a form where we can take the antiderivative? And when we look at g prime in number 1, we see that we can take the antiderivative of this function the way that it's written. Okay, so let's go ahead and find the antiderivative. So antiderivative of g prime is going to be g. And then if I want to take the antiderivative of 5x to the 1/4 power, I can pull the coefficient 5 out front. To take the antiderivative of x to the 1/4 power, I'm going to use power rule. So that's going to be x to the, we're going to add 1 to the exponent. So 1/4 plus 1 is 5/4. And then we're going to divide that by the exponent 5/4. Minus, I'm going to take the coefficient 7 and pull it out front. The antiderivative of x to the 3/4 power, again, I'm going to use power rule for that. So that's going to be x raised to the 3/4 plus 1 power, which is 7/4. And then we're going to divide by the exponent 7/4. And then to that, we're going to add the constant c. Okay, so we just want to go through and simplify this. So dividing by 5/4 is the same thing as multiplying by the reciprocal 4/5. So if I multiply 5 times 4/5, that's going to make that coefficient become 4. X to the 5/4 power minus dividing by 7/4 is the same thing as multiplying by 4/7. So 4/7 times 7 is going to make the coefficient 4 times x to the 7/4 power plus the constant c. Okay, so that right there, that function g is going to be the antiderivative of g prime. Okay, we want to do the same thing with number 2. Now, when we look at number 2, if I want to take the antiderivative of that function, the first term, 5 times the sine of x, is great. I can take the antiderivative of that the way that it's written. But when we look at the next quotient, 3x to the 4th power minus rad x over x squared. Like, I don't know about you guys, but I can't look at that function the way that it's written right there and figure out the derivative of what function is going to look like that. Okay, so what we're going to need to do for that quotient is we're going to have to do some algebraic manipulation to that to put it into a form where we can actually take the antiderivative of the function. Now, the way that we're going to do that is when I look at that quotient, I can separate that quotient into the difference of 2 fractions. The first fraction I can rewrite as 3x to the 4th power over x squared. The second fraction is going to be rad x over x squared. So when I separate that quotient into 2 fractions, then I can take those 2 fractions and simplify them. So we get g prime equal to 5 times the sine of x plus 3x to the 4th over x squared is 3x squared minus rad x, which is x to the 1/2 power, divided by x squared. We subtract the exponent, so 1/2 minus 2 is x to the negative 3/2 power. Okay, now once we have g prime written in that form, now we can go ahead and take the antiderivative term by term. So g prime, I can go ahead and pull 5 out front. The antiderivative of sine is negative cosine, so that's going to become negative 5 times the cosine of x plus. Now, you have two ways that you can simplify the middle term, 3x squared. If you can look at 3x squared and know, okay, I know the derivative of x cubed makes 3x squared, and just find the antiderivative that way, that becomes x cubed, that's totally fine. Okay, if you're not to that point yet, you're not familiar enough to make that jump, then you can just work it through one step at a time. So you can pull the coefficient 3 out front. The antiderivative of x squared is x cubed over 3, and then you would go through and simplify that term. Okay, minus, I'm going to use power rule again for the antiderivative of x to the negative 3 halves. So the antiderivative there, we're going to add 1 to the exponent, so that's x to the negative 1/2 power divided by negative 1/2. And then we're going to add our constant c to the end. And then I'm just going to go, whoops, sorry, that shouldn't be g prime, that should be g. Okay, and then we're just going to go through and simplify term by term. So g of x is negative 5 times the cosine of x. The next term is going to simplify to plus x cubed. And the next term is going to become minus. Minus is going to change that sign to plus. Dividing by 1/2 is the same thing as multiplying by 2. So that's 2x to the negative 1/2 power plus c. And you can leave things in that form. If you want to rewrite 2x to the negative 1/2 power as 2 over rad x, that's fine as well. Okay, either format for that would be acceptable. Okay, let's move on to 3. So 3 is different. Like, we're not given g prime here, we are given g triple prime. So when we look at that, if we want to go from g triple prime to g, we're going to have to wind up taking 3 antiderivatives in this case. Okay, so like the only thing you might want to do in this case to like rewrite this before we can take the antiderivative is to maybe take rad t and write it as t to the 1/2 power. So it makes it clear like that we need to use power rule to take the antiderivative. Okay, so let's take the first antiderivative. So the antiderivative of g triple prime is going to give us g double prime. So when we take the antiderivative term by term, antiderivative of e to the t power is e to the t minus the antiderivative of t is t squared over 2. Or if you want to write that as 1/2 t squared, that's fine by me. I'll go ahead and do it that way. It doesn't matter. Either way is acceptable. So I'm going to write that as 1/2 t squared minus the antiderivative of t to the 1/2 power, which is going to be t to the 3/2 power, divided by 3/2, plus the constant c. So I'm just going to simplify this term by term. So that's e to the t power minus 1/2 t squared minus dividing by 3/2 is the same thing as multiplying by 2/3. So that's minus 2/3 t to the 3/2 power plus the constant c. Okay, and the formatting that for that is good. I can find the antiderivative of each of those terms, just term by term. So the antiderivative of g double prime is g prime. And then we're just going to take the antiderivative of g double prime term by term. So the antiderivative of e to the t power is e to the t power minus 1/2 times the antiderivative of t squared is t cubed over 3 minus, I'm going to pull 2/3 out front. The antiderivative of t to the 3/2 power is going to be t to the 5/2 power divided by 5/2 plus, if we take the antiderivative of a constant, the derivative of what function gives us a constant? It's the derivative of a linear function. So we're going to take c and multiply it by t. Again, the derivative of ct with respect to t is going to wind up giving us c. And then we have to add a new constant at the end. So I'm going to add the constant d. And then I'm just going to go through and simplify this. So g prime is going to become e to the t power minus 1/6 t cubed minus 2/3 divided by 5/2 is the same thing as multiplying 2/3 times the reciprocal. So that's going to be 4/15 t to the 5/2 power plus ct plus d. And then we've got to take the antiderivative one more time to get g. Okay, so the antiderivative here, again, I can take the antiderivative term by term. I don't have to do any algebraic manipulation. So antiderivative is going to be e to the t power minus 1/6. Antiderivative of t cubed is t to the 4th power over 4 minus, I can pull the coefficient 4/15 out front. Antiderivative of t to the 5/2 power is t to the 7/2 power divided by 7/2 plus, I can pull c out front. Antiderivative of t is t squared over 2 plus the antiderivative of d is d times t. And then we're going to add one more constant, e, at the end. And then I just want to go through and simplify term by term. Okay, so that's going to make g of t equal to e to the t power minus 1/24 t to the 4th minus, dividing by 7/2 is the same thing as multiplying by 2/7. So that's going to make 8/105 t to the 7/2 power plus c/2 times t squared plus dt plus e. And that's g of t. And that was a lot of work to go through. Okay, I'm going to have you guys give 4 a try. Okay, so I want you to find g of x given that g prime is equal to 2 plus x squared over 1 plus x squared. Okay, so go ahead and turn or pause the video, give this one a try, and then when you're done, turn it on and then turn it back on, and we'll talk about how to do it together. Okay, so looking at number 4, I'm going to guess, well, number 1, when I look at number 4, I can't take the antiderivative of g prime the way that it's written right now. So it's going to require me doing some algebraic manipulation. Now, if I had to guess, this is what I would guess that you guys did. I'm going to guess that you guys took each term in the numerator and wrote it over that denominator. Now, the good news is we can take that function right there and take its antiderivative. That's going to become 2 times the inverse tangent of x. But the problem we have is we can't take the antiderivative of that function. There's no rule that we have that enables us to take the antiderivative of that function. Okay, which means we have to try something different. Okay, so a technique that you can use in this particular instance, when you have a rational function that is not proper, which means the degree on top is greater than or equal to the degree on bottom, then you can long divide the denominator into the numerator. In order to rewrite, in this case, our function g prime. So when I long divide, x squared goes into x squared once. We multiply 1 times x squared plus 1, and then subtract that result, which leaves our remainder to be 1. And what we can do with that remainder is we can write it over what we're dividing by, which means I can take g prime and rewrite that function as 1 plus 1 over 1 plus x squared. That is equivalent to the function that we started with. When I rewrite g prime in that form, then it's easy for me to take the antiderivative term by term. If I want to take the antiderivative of g prime, that's going to be g. So the antiderivative of 1 is x plus the antiderivative of 1 over 1 plus x squared is the inverse tangent of x. And then we're going to add our constant c to the end. Let me show you another approach that's even easier. What I can do in that numerator is I can rewrite the numerator 2 plus x squared as 1 plus 1 plus x squared over 1 plus x squared. And I can take that numerator and split it into two parts. One is the first part. 1 plus x squared is the second part. So I can take each part of that numerator and write it over the denominator. So 1 over 1 plus x squared plus 1 plus x squared over 1 plus x squared. Which means I can rewrite g prime like this. 1 over 1 plus x squared plus that second fraction is going to wind up simplifying to 1. And then we can go ahead and take the antiderivative of that as well, which gives us that function g of x also. Okay, so like I said, there are going to be some functions that you can just take the antiderivative of immediately. And there are other functions where you're going to have to do some type of algebraic manipulation in order to take the antiderivative of that function. Okay, so that wraps up part 2. We'll move on to part 3 next.